Mask on. Stay away from everybody. Don't be breathing in other people's breath. So today we're gonna start with naming chemicals. How we name chemicals. Y'all ever watch like the drug commercials? And they're like, this drug is called da 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 Zetafil, and they have all these names and they're real long, and then the names are terrible and you can't remember them, so they come up with like trendy like brand names like Allegra and what's the I don't know the names of them. Well, Advil, yeah, I guess, but Advil's like an older one, so but yes, like Advil is not the name of the chemical that you take to help you with headaches. Advil's like the brand name, not the chemical name. The chemical names are usually longer, and they actually do describe like what you have as a chemical. And so today we're going to start the basis for that and how we kind of build up to naming chemicals or knowing what the chemical names are based on their formula. So today we start with ions. There are going to be like 5 or 6 assignments in this little section before we have a quiz over it. So like I said, make sure you keep these sheets because we will use them for at least like 5 assignments. And if you lose it, I might be able to print you out another one, but if I'm out of copies, you're going to have to use the digital one. No, also, if you like the digital one, it's already up on Google Classroom, and it's obviously in Sapling. So, learning objectives, what are we going to do today? We're going to learn to name and write formulas for ions using the IUPAC nomenclature rules, which is just a set of rules that we all kind of use. What are ions? What do ions have? They have charges. Ions have charges, either a positive or a negative charge. So we're not getting complicated. We're just doing really like single element kind of things, or we'll have a list of multi-element ones. So first off, an ionic compound, which we'll get into bonding soon in this chapter. An ionic compound is a compound composed of a cation and an anion. Which one's positive? Which one's negative? Cation's positive, anion's negative. And what do positive and negative things do? They attract. They're going to be attracted together. And so that's what we get when we have a chemical like salt, sodium chloride. You have an Na and a Cl. If you look on your periodic table, NaCl, where's sodium at on the periodic table? It's in that first column. So how many protons does it have in its valence shell? 1. It only has 1. How many does chlorine have? 7. And how many do they want to have? Oh, sorry, my bad. Yeah, my brain like fast forwarded a little bit there. 7. And they want to have 8. So what is sodium going to do with this 1 electron? It's going to give it up. So this electron is going to come over here to chlorine. Sodium's going to go down to 0. Chlorine is now going to have 8 electrons, which makes sodium now has 1 less electron than it's supposed to. So it has an extra positive charge in the nucleus compared to the electrons. So sodium's going to be positive. Chlorine is going to be negative. And now that positive and negative charge attract to each other. And that's what helps them combine to form salt. It's also one of the reasons when you put salt in water, what does it do? It dissolves. Yeah, it actually comes apart because there's not actually a real strong bond between these two atoms. They're just attracted by their charges. And so when you put them in water, water pulls them apart, and you have like your beaker of water here. That's not a great one, but you have lots of little NAs, Na pluses floating around, and Cl minuses floating around. Well, that should be a lowercase l. I'm just messing up everywhere. But they separate and they ionize, and they're just floating around in the water individually, as opposed to like a combined crystal that has both of them. So that's what an ionic compound is. Composed of a positively charged atom and a negatively charged atom, a cation and an anion. We know cations are positive. Forms when you lose 1 or more electrons. Anions are negative. Forms when you gain 1 or more electrons. Now, terms. Monatomic. What does mono mean? 1. So monatomic is going to be an atom that only has 1 element. It's not going to be a polyatomic ion, which has many different elements. A monatomic ion only has a single atom, gains or loses 1 or more electrons. It's going to be very simple. So your metals, like we already said, metals, have less electrons in their valence shell, they're going to lose those electrons to form positive cations. Your nonmetals on the right side of the periodic table are going to gain electrons to form negative anions. And we can predict the charges for the ions of the main group elements using the Lewis dot structure. Just like we did here, we didn't know before we started what sodium and chloride would be, but we know sodium only has 1, chlorine has 7. The sodium is going to give up that 1, so it's going to be a +1 charge. Chlorine is going to take in that 1. It's going to be a -1 charge. We can predict that based on where they're at on the periodic table without having memorized it. Let's do another example. Mg and S. So magnesium sulfate. How many does Mg have? 2. And when it gives up both of those 2, what's the charge going to be? It's going to be a +2. Yeah, so you can have Mg +2. And then sulfur has how many? 6. So it's going to take in those 2. And what's it going to be? -2. So it works the same. It's just the number of electrons that you give up or take out. And you can guess most of those atoms just based on where they're at on the periodic table. Now, they give you that example here. Sodium loses that electron. It becomes positive. Now, how do we name these? Cation naming pattern is your metal's name, just plus the word ion to the end. And so if we know it's an ion, we know it's a charge. This is actually really simple, yeah. If it's sodium, it's just going to be called a sodium ion. If it's magnesium, it's just going to be called a magnesium ion. That's probably one of the simplest ones. To name a cation, you just tack the name ion to the end. Sodium becomes sodium ion. Your nonmetals will be a little bit different. So they have their examples here. You can see everything here is a +1. Everything here is a +2. You skip over the metals, the transition metals, which can be a little bit weird. Everything in this column, well, down until you get to your regular metals, is +3. The +4s and the +5s don't really fall under this so much. It gets a little wonky in the middle. But you have -1s, -2s, maybe a -3 here, depending on the atom. Now, group 8A nonmetals have full valence electrons. These are your noble gases. They're not going to do this at all. Noble gases aren't going to lose electrons or gain electrons. They're going to stay just like they are. They have that octet already. So they don't form ions. But your halogens, 7A, they have 7 out of 8 electrons. They're going to gain that 1 electron. So when they do that, they become negative. And how do we name that? We put an "ide" at the end. So instead of chlorine, which is your element, what's the name of the ion going to be? Chloride. And then when we put those 2 together, what's the name of salt in your chemical name? Sodium chloride. Yeah. We don't just say sodium chlorine. It's sodium chloride because we're acknowledging that it has a negative charge and a positive charge. So we'll get to that in a second, but I was just fast forwarding a little bit. So if it's a metal, you just tack the word ion to the end. If it's a non-metal, you add the "ide" suffix to the end of the base name. So chlorine would be chloride, sulfur would be sulfide, oxygen would be oxide. Does that make sense? Just take the root of the word and add "ide" to the end. They do the same thing with oxygen. That would be a -2 charge. Nitrogen would be a -3 charge. What would nitrogen be as an ion? It's a nonmetal, so what do I do to the end of it? Nitride, yeah. So like oxide, nitride, yeah. So you just add the word "ide" to the end, or the ending "ide" to the end.
Like every time?
If it's a nonmetal. If it's a metal, you just add the word "ion" to the end. So like any of the metals over to the right, calcium would be calcium ion. Strontium would be strontium ion. Now they do point out hydrogen can become a cation or an anion. How many atoms or electrons does hydrogen have in the valence shell? Just 1. But what's for that top row? What's the most that hydrogen or helium can have? 2. Yeah, it's not going to get up to 8. So 1 electron is just as close to 2 as it is to 0. So hydrogen can give up an electron or can take an electron and become positive or negative. It's a little bit special like that. So a positive hydrogen would be hydrogen ion. A negative hydrogen would be what? Hydride. Yeah, you add "ide" to the end. Hydride ion. Now, polyatomic ions are a little bit different. These kind of follow a naming rule, and for the most part, for this class, you're going to have a list here. The list is going to help you out. You just need to find the name of the atom and find it on the list and match up the formulas. But we have quite a few of them. Acetate, C2H3O2, it's a -1 charge. And you can go down all of these and see the charges that they have and have the actual name that we have for it. Ammonium is NH4. It's a +1 charge. You have carbonate, chlorate, chloride, chromate. I will say these, like chlorate and chlorite, kind of follow a naming convention that we'll get to in a second. It depends on the number of oxygens that atom chlorine is attached to. And so there is a little bit of a formula for that. But for the most part, a lot of this stuff on here, you will just find it on the list and match it up to what your answer should be. So if it has an oxygen, which not everything on this list does have an oxygen, but almost everything does. If it has an oxygen, we call it an oxyanion. That is the name for any polyatomic ion that contains oxygen. So it has to have something else besides the oxygen. But if it does contain something else and an oxygen, we call it an oxyanion, indicating that it's both an ion and it has oxygen. Naming oxyanions has a weird pattern. So you take the name of the element that's not the oxygen. So let's say we go back and we have chlorite and chlorate. So see these two here, chlorite, chlorate. It's a chlorine and an oxygen. The first one is chlorine and 3 oxygens. The other one is a chlorine and 2 oxygens. How are we going to name these? You take the root of the other element, in this case it's a chlorine, and you put it in each of these 4 names. So chlorine and oxygen, based on the number of oxygens you could have, could be perchlorate, it could be chlorate, it could be chlorite, or it could be hypochlorite. And that all depends on the number of oxygens you have. Now, it's all going to be a little bit different. You kind of have to be more familiar with chemistry than we're going to be, because one of these is going to be the most common one, and then you kind of go up or down from there. But for chlorite or chlorate or whatever you have, if it has 4 oxygens, it's perchlorate. If it has 3, it's chlorate. If it has 2, it's chlorite. And if it has 1, it's hypochlorite. And you can see they have the greater than symbols here. The per8 is going to have the most oxygens, and then it just goes down in oxygens, 1 oxygen at a time, until you get down to hypoite. And so each of these have a different number of oxygens. Notice they're all only a -1 charge. And so they all have the same charge, just a different number of oxygens. They all have 1 chlorine along with them. And so this does get a little bit complicated. And when you get to these problems, you're really going to have to think about how you get to the correct answer. And obviously, I'll be here to help you out a little bit. But I'm going to leave this up because apparently we're to the end of the PowerPoint. So go ahead and start on the assignment. And I'm going to actually look through the assignment too and see if there's anything I need to go over with you. Resume. Number 2.
That's not the one I have.
No, but yours is positive, right?
Mine's minus. That's what I'm having trouble with.
Yours is minus. So wait a second. Give the name of the Ba2 ion. Careful of your spelling. Do not include the word ion in your answer because they already have ion at the end. So on this one, I would just type out barium. It should just be barium ion. What is the one you have?
Fluorine.
Wait, fluorine? Yeah. So fluorine is it a metal or a non-metal?
Good question.
Well, look at it on the periodic table. Is it on the metal side or the non-metal side?
Good question. It's on the right side.
Okay, which is where? Look at the colors and the key there. Huh? Yeah, non-metals. You don't have to guess. It's right there to you. But yes, fluorine is a non-metal. So how do I change a non-metal name to an ion? What do I add to the end? Ide. So instead of fluorine, it should be fluoride.
I put enide.
Yeah, no. Don't. You get rid of the ene and add the ide.
What if it's a metal?
If it's a metal, it should just be. Okay, now this one. Okay, hold on a second. Let me show you this. So it doesn't work out for barium this way, and this is going to be for your copper and for your iron. So you have copper right in the back. What's your charge? Just a positive? Oh, positive 2, and yours positive 2, right? Oh, 3. What you need to do for metals, I'm gonna borrow this for a second, that are in your transition zone in the pink. If you get a metal that's in the transition zone, you need to put the charge in parentheses in Roman numerals. So after iron, open up parentheses and put I because you have a +3. For copper, open up parentheses, put I, 2 Roman numeral 1s, close parentheses. That's going to be your answer there.
Like FOI?
Hold on a second. I'll be right over there.
Sorry.
So iron, put I think a space.
This?
You can just do capital I. I don't think you have to do anything special. Yes. Close that. I don't know why it's not doing that.
Is that right? If an ion contains 2 or
Maybe
more
put a
atoms
space.
of the same
Let's see if it takes that.
element.
Oh.
And me and Eli are
Oh, are you doing the wrong thing?
Yeah.
lead. We already asked him.
We already asked him.
See, there you go.
We
Yeah,
already
Did that work for you?
Right here.
Cool, cool,
No,
cool.
we already
You're
asked
right.
him. No, we already
Yeah,
asked him.
Wait, hold on.
Right here.
So lead, what's your charge? +2. And lead is going to be, it's not
Wait,
in these, but it's going to work the same. If it's +2, do lead Roman numeral 2. So open parentheses,
Not alone.
put I, close parentheses.
Is the monatomic one just the positive ones?
You were not alone.
Nice, good job. Huh?
Is
Hey,
monatomic positive?
It's me next, okay?
It depends on if it's a metal or non-metal. So look and see. Oh wait, no. Monatomic will only have one element. Polyatomic will have different elements
Okay.
Okay.
That
So,
looks like it.
or different multiple atoms. It can even be the same element.
Hey, what?
So what do you got?
how is that
Wait.
wrong?
Hit big screen so I can
Wait,
see what
yeah.
your boxes are. Scroll up. So monatomic N3 has 3 atoms. That's polyatomic.
I see this.
That might, yeah. If it's more than 1, it'll be polyatomic. So I think that was the only one. Let me see. Well, no, that's your charge. See the 3's on the bottom there? That means I have 3 atoms
But there's
together.
4 on the top.
That makes sense.
No, if it's on the top, that's just the charge. So I think that was the only one you had wrong.
You're so right, Mr. Manning.
I think I got it.
God bless
All right, cool.
I didn't do it.
Hold on a second. Let me pause this.